I am. I work in Amsterdam, backend developer for Booking.com, and I'm a fanboy of Sawyer and Steven. They taught me everything I know about Perl. Husband of one, father of two. Yeah, these hairs are here for a reason. Yeah, I've lived many places, done lots of things, get off my lawn and all of that. By the way, Booking is always hiring, so if you're interested, let me know. Okay, so why? Why would you be interested in joining or making JavaScript work inside Perl? There's a technical answer, right? So why not? I mean, the thing is there, and you can do it, and you can write whatever code you need to make it run. So I'm not going to talk about that because I'm pretty sure all of us here would be interested in this kind of project. I'm going to give you a few of the reasons why we wanted to experiment along this way. And the summary is, it's having a kind of a Node.js, but in Perl. So not throwing away everything we have in the backend, which is today running on Perl, but also having a way of running JavaScript for the front end in the backend. So we do have a huge code base in production, millions of lines of code running in production. The backend is mostly Perl. We have some pieces now running also in Java, not JavaScript. The front end is Perlish. There's lots of Mason in there. Anyone here has done work with Mason before? Okay, not a lot. Anyone here likes working with Mason? You're in the correct room. Great. We have found that it's been almost impossible to modernize our front-end code, and we want to. And I'm going to go into a few of the reasons for that. So at some point, we started wondering, OK, so can we fake this? Can we not throw away the millions of lines of code in Perl and just put Node in there and migrate everything there, which is impossible? Can we fake it so that to the front end, it feels like we have something like Node, but in the back end is actually a shallow layer of JavaScript running actually on top of Perl? So can we do this, keeping all of that Perl backend pretty much untouched? So one of the reasons to do this, and I think we're not going to have a lot of time. I'm going to go over this very quickly. So there's a thing called server-side rendering, which is very important. When you move to something like Node and you go to one of these newfangled frameworks like, I don't know, Vue or React or whatever, many people fall under the temptation of doing it pure client-side. So like a single-page application where everything runs in the client. And that has a whole set of problems. And keeping the ability to run code server-side and to render the page server-side has a lot of advantages, like what I'm mentioning there, better search engine optimization and faster time to content. And of course, there's some issues with it as well. The usual thing about client-side rendering when you go to a single-page application is that you load a page, and we've all been there, and you see loading, loading, loading. Even though the page is actually doing different parts of the life cycle, you don't get the page. You're not able to see anything until everything has been loaded, because everything is actually running client-side. So the client is pulling all of the stuff, and it doesn't have anything for you ready until it has finished rendering the page. Whereas where you have server-side rendering, the first time you hit a page, you do get stuff that gets sent back to you as soon as possible. You do get to see the contents of the page before, while the client is still putting together and completing the page. But you do get a what feels like a more interactive experience. So we didn't want to lose that, because Mason gives you that. Mason does server-side rendering. Okay, another reason why to do this is front ends also deserve to be happy, right? So it's not just a world of backend developers. They want to use modern tools and frameworks, and they actually want to use proper front-end stuff, and not something that's back-endish, that looks like front-endish, but it's actually Perl in disguise. We have found, surprise, that it's actually quite difficult to hire front-end developers when you tell them they are going to be working with Mason. And yes, it is a reality that front-end frameworks, JavaScript-based frameworks like Vue and React, and I don't know how many more, they come and go. I'm not judging about that. They want to work with them, and we found it was our place to just give them a way to do it. Okay, so what it is that we did. We started with Duktape. Duktape is a embeddable JavaScript engine with a focus on portability and compact footprint. That's how they define themselves.
I'm looking for my back.
Oh, okay. Yeah, not here. So Duktape is a JavaScript engine that's written in pure C. It's very easy to work with, just basically like 2 or 3 source files that you plump into your directory and compile, and that's it. It works with pretty much any C compiler. Embedding it in XS is plain vanilla embedding. Anyone here has done XS wrappings before? Okay. Okay, I commiserate with you. There are no external dependencies for Duktape at all, so just those 3 files, and that's all you need. It's pretty fast. It's actually a compiler, so it compiles to bytecode, like Perl does. It runs on a stack machine, so this is where the speed is not that good. And we found that although it has all those advantages, it was not fast enough for what we needed to do. So then we said, okay, we embedded Duktape, works. It looks like what we want to do works. Could we embed something faster? So we went to V8. V8, according to their own page, is Google's high-performance JavaScript engine. It's written in C++. So it's harder to work with. It's more complicated. The API is much, much larger. It also requires a very modern C++ compiler. So this is where things start getting a bit complex, because if you have an already existing runtime environment, maybe you will not have the appropriate C++ compiler for that. So you need to take care of that, and so on and so forth. It's also harder to embed with XS because it's C++ and not just pure C. So XS supports that, but then again, you're straying far from the usual XS embedding. It also has some external dependencies. One of them is ICU for all the Unicode handling. So we found that the version of ICU required by V8 clashed with a bunch of stuff that we had already in production, so it was a major pain in the ass to fix that. So this took much longer than Duktape. On the other hand, it's not very fast. It is amazingly fast. And I'm going to show some numbers supporting that claim. It is a compiler. It's also a just-in-time compiler that actually compiles to machine code, the hot pads of your code. So it does that during runtime. And it was easily fast enough for what we needed. So we said, okay, if maybe we could prototype with Duktape and then move to V8. But then we would need the wrappers that we wrote in XS to have certain characteristics. So how did we do this? At this point, we were just getting out of the prototyping step, and we were actually trying to come up with a way of putting this in production. So we realized that we needed a kind of like a universal API. So both engines running in the same way as far as a Perl developer was concerned. One thing I have to point out is that both engines had an existing Perl wrapper already, but they were different. So if you were using the existing wrapper for Duktape, or you were using the existing wrapper for V8, they had different APIs. So it was not just, you cannot just switch from one to the other easily in your Perl code. So this is one of the reasons why we came up with our own wrappers. And there are some other technical reasons that I can share with you. Just find me in the hallways and we can have a chat. So we decided that we wanted this simple universal API for both. So first, we wanted it to be object-oriented. So you can just create this virtual machine thing for both Duktape and V8. You can give it some options, but you don't need to. You can also set and get JavaScript variables from Perl. So there I'm setting foo to that array, which also means converting that array and the nested contents of the array into JavaScript values to be stored in the JavaScript engine. And of course, you can get it back. And the third large piece of the API is to evaluate a piece of JavaScript code. So you can just eval something and you get what you would expect. The universal part is there in the class. So this works exactly the same for Duktape and V8. Just changing the name of the class is all you need. So of course, there's other stuff you will want to do with your API. So you need to be able to, well, you don't need to, but this is the way we did it. You can pass a Perl sub into JavaScript, so it becomes like a JavaScript function. So when you're running the JavaScript code, if there is a call to that function, it actually calls back into Perl. It passes data back into Perl. You run your Perl code, and then Perl returns something that gets converted back into JavaScript, so JavaScript can keep going. So it goes both ways. You also need a way to, when you're doing JavaScript, set timeout a function after a certain amount of time. You need a way to dispatch all of the pending timeouts. Maybe those timeouts will create more timeouts to be dispatched. So you need a way to do that, to control that. You need to support console output, some specific JavaScript stuff that's required. A way to trigger garbage collection. It's useful. And also a way to fetch all of the names of all the global objects that you have created in JavaScript. And of course, there's this is where it got interesting technically. You need to marshal data between Perl and JavaScript in a way, hopefully, that's two ways. So you need to handle the basic nested data problem. You also need to handle blessed objects in some way. So what we did is we just ignored the fact that they were blessed objects, so you convert them to JavaScript, and when you get them back, they are not blessed anymore. You need to deal with data that can almost be round-tripped, like Booleans. Perl doesn't have a concept of Booleans, so if you take a true value in JavaScript and convert it to Perl, you get something that when you want to send back to JavaScript may not be a Boolean anymore, but JavaScript does differentiate between them. So you need ways of dealing with those. Same thing with the difference between integers and floating point numbers. JavaScript doesn't have integers. Surprise, maybe. Anyone here didn't know that JavaScript didn't have integers? Okay, now you do. Yeah, only floats. Yeah, not judging. There's data that just cannot be round-tripped. So you have a JavaScript subroutine that you want to send back into Perl. That just doesn't work. V8 does support this in a very complicated way, because Duktape doesn't support it, and we wanted to control the power that we gave our developers. We said, no, you're not going to be able to do this. You need to deal with Perl magic in some cases. So you need answers for all these questions, and we do have answers for them. Output from JavaScript, you need to know to decide what to do. You store it, and then you fetch it somewhere, or you just intersperse it with Perl output. How to handle fatal errors in JavaScript, you need to do something with them and maybe bubble them up so that they become dies in Perl or something like that. So it says examples, but I only have actually one example. I thought that was a very good question. What the hell are they celebrating Christmas? Prehistoric men? Okay, I don't see from here. Okay, so I'm gonna run over this. So this is a Fibonacci implementation in JavaScript. If you see there, that's the only difference between the two implementations, Duktape and V8. The rest of the code is the same. So I'm not going to show the boilerplate anymore. That's all the differentiation is by the class name that you're using. So this is an example of running that code. You see there that Duktape and V8 on each side. The results are the same, which is awesome. And of course, the runtime is not the same. So Duktape takes 3 minutes, 20 seconds, and V8 takes 0.2 seconds running that code. Fibonacci is an exponential algorithm, so it makes sense that you would see that kind of behavior if you put it in a log scale. And the yellow is a C implementation of the same algorithm, just as a baseline. You see how much more speed you get from V8. Okay, so what have we done with this? How are we using it so far? We examined several JavaScript frameworks and chose one of them. But I didn't do that. And we made the native Vue framework supporting server-side rendering run on our Perl Frankenstein monster. And we're currently migrating actual sets of pages from Mason. So we're moving all of the backend logic to Perl classes that are exposed as service endpoints, which can be called either locally during server-side rendering or remotely from the client. And we moved all of the front-end logic to Vue templates, which are universal. So the same Vue template can run during server-side rendering or client-side rendering, on the server or in the browser. So we're just about to serve 60% of our site's live traffic with Vue, so this is not an experiment anymore. It's actually running production code. It's not the Booking.com visible site. It's a site used by our partners, but it gets between 20 and 60 templates rendered per second during every day. So it's pretty high volume. What are we planning to do? We want to support better sandboxing, so limit the memory allocation and execution runtime. And this is my plea for help. There's a new engine on the block, Quick JavaScript, written by this crazy French guy, Bellard, the guy who wrote the Linux emulator that runs on your browser. Yes. It's awesome code, pure C. It's much faster than Duktape. There's not a lot of documentation, so I have found it hard to get all of the information I need. So if any of you want to help, just pick me. And those are some of the things I mentioned during the talk. I don't think we have time for questions.